In this lesson, we are going to be writing equations of cubic functions. So if we recall from previous courses, our 2 points determine a line so that we can connect them together to create our line. 3 points determine a parabola because we need to get that general shape. And 4 points would determine a cubic function because, again, we need to get that general shape. So how to write a cubic function? We would use factored form. We would use x-intercepts to find the factors, and then we use the other point to find the a value. In this first example, we are writing a polynomial function of least degree that has real coefficients, the given zeros, and a leading coefficient of 1. So we recall from our previous lesson that if we are working on this problem, that these are our solutions. First of all, since one of our solutions is imaginary, we know that we also have to have another solution that is imaginary because imaginary solutions always come in pairs. In the directions we are given that we want the least degree, which means we're not going to add any more. We know that our leading coefficient, our a value, is 1. So since these are our solutions, what we will do then is to bring the solution to the other side, which would be then becomes our factor. So we would have x plus 1, x minus 2, x minus 2 plus 3i, and x minus 2 minus 3i. And that's a review from our previous section. So now when we go into writing cubic functions, we need to use 4 points because we are not using an a value or leading coefficient of 1. We need to find what that coefficient is. So when you're writing a cubic function, we would have y equals a, x minus p, x minus q, x minus r. The p, q, and r are going to be our x-intercepts. So if we take a look, our first x-intercept is going to be at -3, 0. Our second x-intercept is going to be at -1, 0. And our third x-intercept is going to be at 3, 0. So we know that x is equal to -3, x is equal to -1, and x is equal to 3. These are going to be our p, our q, and our r. We need one other point in order to find our a value, our leading coefficient. So this is the one that we've been given that we know is exactly on a corner or an exact point without fractions or decimals. And that's going to be at -2, +1. So we're going to use this as our x value and this is our y value. Now we're going to plug in all the values to solve for a. So our y value, we're going to plug in a 1 from our point. We don't know our a value. We're going to use our x value as -2, and we're going to subtract our p value. Our p value is -3, so minus -3 would be +3. Our x value is -2, and we're going to minus our q value. Minus -1 would be +1. Our x value is -2, and we're going to subtract our r value, -3. Now we're going to go through and do our math. So -2 plus 3 is 1, -2 plus 1 is -1, and -2 minus 3 is -5. So we have 1 equals, and we're going to multiply 1 times -1 times -5, which would be 5. Divide both sides by 5, so our a value is 1/5. So when we write our equation, we're going to have y equals 1/5 And then we have our x value. We won't plug in the x, but we'll just plug in the p, the q, and the r to represent our function. So we have x plus 3, x plus 1, and x minus 3. We leave the x value and the y value as variables, so it represents the entire function instead of those specific points. So let's try another one. So here's our p, our q, and our r. And here's our other point, and that's going to be at 0, 4. Our x is going to be 0, and our y is going to be 4. So we have y, 4, equals, we don't know our a value. Our x value is 0, and we're going to minus negative 1, which would be plus 1. 0 minus 2, and 0 minus 4. Now we're going to calculate. So we have 4 equals a times 1 times negative 2 times negative 4. 4 equals 8a. Divide both sides by 8. So we have 1/2 is equal to a, and that's going to be our leading coefficient. So when we write our equation, we have y equals 1/2, and then we have x plus 1, x minus 2, and x minus 4 as our factors, and we're leaving this in factored form. In the following example, we know when we have x-intercepts because they begin with our x value, and we have our y value as 0. So these three are going to be our x-intercepts, which could be our p, our q, and our r, and this is the point we'll use for our xy. So we have 4 equals, we don't know our a value, that's what we're solving, 1 minus 0, 1 minus 3, and 1 minus 9. So we have 4 equals a times 1 times negative 2 times negative 8. Multiplying those values together, we get 16, and when we divide both sides by 16, we know that our a value is 1/4. So when we write the equation, we will have y equals 1/4 times x minus 0, we could just leave as x minus 3, and x minus 9. And that will be the equation for our cubic function. Excuse the extra notes. It looks like I had those on here, and we don't need those for this particular section. And that would be it. So this would be writing equations of cubic functions.